Hello and welcome to this Ensemble video. In this particular Ensemble video, I will show you how you can use weights based on the forecasting accuracy of two different methods to create ultimately an ensemble solution. So for this particular illustration, I'm going to use the mean square error and the standard deviations of the both methods, and we will calculate weights based on that. So assume that we have two models, model A and model B. So the weight for model A will be the ratio between MSE of model B divided by the standard deviation of model B. Overall, MSE of model A divided by standard deviation of model A, and obviously MSE of model B divided by the standard deviation of model B. And after we calculate the weights for model A, we will just calculate the weight for model B as 1 minus of weight of model A. And after we calculate the weights, we're going to multiply each weight along with its respective forecasted values, and we will just add those two numbers to get our final ensemble solution. To illustrate this, let's look at our example on Amtrak. So assume that we have two models, two best models, and let's say first one is a Holzwinter's alpha value of 0.2, beta 0.15, and gamma 0.05. And the other model will be, let's say, a regression model with polynomial trend, and let's say seasonalities which are based on monthly. So what I will do is I will run these two models on this particular data set. I'm going to create the dummies to run the regression, and then I will use Ensemble to match these values. So first thing I will do is, since my plan is to run two different models and these are the best models so in our mind, so we're not going to partition this data set. So first I will do is I'm going to create the reasonable variables I need to run the regressions. So I'm going to first create the two columns. T is a time index, and then I'm going to create the t square column. And after I do that, t and t square, I'm going to now create the dummies for this data set. So this data set, obviously the seasonality is monthly, so therefore we do need to create 12 dummies and to capture seasonality. And if we are running a regression, we're going to use only 11 of those 12 dummies. So to do that, the best thing will be to use the power of Excel Miner, and what I will do is I will just create this column called January, February, March, and so on and so forth, and then I will use this particular variable to kind of create our the dummies, and I will use the Excel Miner approach to do that. So as I'm creating these variables, you also, if you're doing it along with yourself, please do it in the same time. In that way, you can follow what we are doing. So that's it. So what I have here is I have now, let's say I have identified my the month and date. So with this information, I am going to now create and create my categorical data, create the dummies. So to do that, I'm going to go to transform, then transform categorical data, and then I will click on create dummies. So what I will do is I will select month date, the variable I just created, so that the Excel Miner will use this as a factor to create the dummies. So what I will do is, as soon as I click OK, you will see a new tab called encoding, and based on that month date column, now we have dummies for each of the months. As you can see in Excel Miner, all these dummies are alphabetically ordered. So it's not January, February, March, but it starts with April, August, December is alphabetically ordered. So now what I will do is I will now in order to obviously use this to create new 12 values, let's say our goal is to create new 12 values. I'm going to create a new spreadsheet. I will name it as future value. Now the whole reason of doing this is so the Excel miner can figure out from which spreadsheet they should create use information to forecast the new values. Obviously, this approach is not necessary if you're using a smoothing technique like Holz Winters. So the first thing I will do is I'm going to copy and paste all those variables. I will also do one more thing. Since the original data set did not include the dummies, we do need to create the dummies. We need to create dummies on the raw data, so we can use that to obviously forecast future values. Because when you are forecasting new values, you do want to make sure that you are selecting the whole data set to do that. So what I will do is just to keep it simple, I'm going to copy paste the spreadsheet from encoding to this sheet 1. So in that way, when I'm going to tell the program to forecast new 12 values, I'm going to use direct sheet 1 as our raw data. So the next steps will be to kind of extend this data set by 12 values, given that that's what we want in our forecasted horizon. So our forecasted horizon or goal of this particular data set is to obviously forecast the next 12 values. So what I will do is I'm going to extend this data set, and that's a better way of doing this. So I'm going to extend this data set by 12 values, and then I'm going to now use that. So extend this by 12 values, and whatever I can, for example, I can calculate the t and t square for this data set, because those are the ones that are obviously and those are the ones I think I should just do this hat to so these are the ones actually, because we can do the month is obviously in Julian days, so there's no point in converting there. Ridership is what we want to forecast, so we don't have any values for this, and then we can only have the t square and the dummies. So to do that, I'm going to just look at the next previous 12 values, and I'm going to just copy paste this just to match this, because really the next 12 values is nothing but the last 12 values, right? So that being said, what in the next step of this approach would be to kind of copy this, actually cut it and paste it on the new spreadsheet we created. So I'm going to just cut it just to make sure, cut it, and then we just paste it. Looks like I had added a new extra row. I'll delete this extra row, so I'm going to cut this. First I'll delete this extra row I have, then I will also delete any column that has missing values. So month, record, ridership, we can just delete these columns. Okay, and I'll make sure that the control of this sheet 1 is on a data set, otherwise it's going to give some errors. So the first thing I will do is I'm going to now use the predict function and linear regression to run the polynomial of order 2 and with dummies to create new 12 values. So to run that model, our ridership is our output variable. T square are the two independent variables to capture the polynomial of order 2 trend. and then I need to just select any 12 dummies. So for no reason, just for demonstration, I am just not selecting April, but I'm selecting all other dummy values for other months. Then I'll click next, and then I will well, you can choose coefficients and residuals if you really want to do some analysis, but for illustrations we don't have to do that. Then I will just select detailed score for training. We do need that so that we do get the training errors to calculate the MSE and SDs of the model. And then I will select score new data in worksheet, which will allow me to kind of direct Excel Miner to this new spreadsheet I've created. And when I click match by name, I am telling the program that the variables we have in this future data has the same meaning as the variables we have in our raw data. But as you can see, since April is not part of our model, it is not linked. Okay. So when I click finish, what I will find is I will find a new spreadsheet called linear regression new score with the new 12 values. Along with that, if I click on the training score spreadsheet, I'll also see the residuals. So the goal will be to kind of use these residuals as, let's say this is model A. I have to calculate the MSC and SD of these residuals and use that into the weight calculation. So before we move to running the whole sprinters, let's calculate the mean square error and obviously the standard deviation of this residual. And we will use those to capture to do our ensemble calculation. So to make things easy, I'm going to create a new spreadsheet, a worksheet, and I'll say it's ensemble worksheet. So in this way, I can just copy paste what we are doing. I'll say ensemble worksheet. So in this way, I can then just make sure I keep track things on. So I'm going to now copy these ridership values. These are the new 12 values we got by running the regression approach, and I'll put it here. So I can make all the final calculations in this particular spreadsheet. Then the next thing I will do is, before we run the whole winters, I'm going to now calculate the mean square error of our training score. So do the mean square error, what I will do is I will calculate, create a new column called our, it's a residual square, because that's what we want to do. Now I'm going to square the residuals. So I'll square each of these residuals. I like doing the hat in this way, it's easy to kind of calculate. And then we need to just do the mean value of these residuals, and that will give us the mean square error. So if I just do the mean, which is nothing but I go to home and select the average of these values, that is our mean square error. Now to calculate the standard deviation, what I will do is I will just type a standard deviation just for my record here, STDEV, and then I'm going to use the standard deviation of the squared errors. So what I will do is, since this is a sample, I'm going to use the standard dev.s formula, and then I'm going to select the squared residuals of the training period. The reason of doing that is we are actually looking at the mean squared error, and therefore to get the weight we have to divide it by the standard deviation of the squared errors. So that's the value. So my two values here is MSC is our 4,812, and the standard deviation is 7267. Next, I will copy these values, the MSC and then the STD of this model, and save it in the Ensemble column straight spreadsheet. So later on I can use these numbers to obviously calculate my weight. So what I will do is I'm going to now next is going to now focus on how we can run the next model, which is the model B, a whole winters with the default alpha beta gamma values of zero point 0.2, 0.15 and 0.05, and then I will tell the program to forecast next 12 values, and then in a similarly I'm going to calculate the MSE and standard deviation of those of the new model, which is our whole winters, and then use those numbers along with the new weighted values from that model to calculate my ensemble values. So what I will do is I'm going to go to my sheet 1, and in this case I'm going to now go to data mining, and then I'm going to click on, it's coming up, yes, we have some license here. So data mining, I'm going to come up, and then so I'm going to go to data mining, and then I will go to smoothing technique, whole winters multiplicative. I'm looking at the raw data, which is our the whole data set. My selected variable is ridership, month is time, my period is 12, that is the seasonality, the alpha, beta, gamma values are default, produce forecast, and I look for 12 new values. So what I will do is I will now, when I run this, I got the 12 values under the spreadsheet called Mult Holt Winters. And so here are my 12 values, as you can see on the right hand side. Let me close this. So here are my 12 values, which are from let's say a whole winters multiplicative. I'm going to copy these 12 values, paste it under ensemble, and then I'm going to go back to the whole winters and calculate the residual square. So the plan will be I'm going to use this residual values to calculate my MSE and obviously standard deviation of the squared errors to calculate the weight. So I'm going to use the hat2 formula, and so that's my residual square. So first what I will do is I will calculate the mean squared errors of this residual square. So I'm going to go down to this particular spread, this column, and it's nothing but squaring these values. So I'm going to type MSE. So I'm going to write MSE is MSE equals, in this case it is equals square average of obviously average of these 12 values. So what I will do, no, not 12 values, average of these values in my residual square. So that will give me my mean squared errors. Okay, and then I will use that. So averaging them will give us the mean square error, and after that I'm going to calculate the standard deviation for this error squared. So that gives our MSE, and then standard deviation will be once again the standard deviation of the sample standard deviation. So I'm going to use that, and then I'm going to use this and obviously select my residual square column, column H, and that's my standard deviation. So these are my standard deviation and MSE values for our whole winters model. So I'm going to copy and paste these values here. So in that way we can then create, just to save these, in that way we can create let's see, you can get the formulas and then run the models. So once again, this is my MSC, and this is my standard deviation of the first model, which is our regression model here, and then obviously this is the MSC of the Holz-Winters model, and this is my standard deviation of the Holz-Winters model. I'm going to just put them in the same order so it's easier to kind of use the formula. I'm going to delete these two rows. So now next step will be to now calculate the final output, which is our ensembled values. So the plan is I'm going to first create the weights, okay, and then use that to obviously to add the things. So to create the weight, model A, let me write it down, model A and model B. So model A and model B, we have two models. So the weight of model A is, it starts with the MSC of model B, MSC of model B divide by standard deviation of model B. So that's our numerator, okay, divide by MSC of model A divide by the standard deviation of model A plus, so I'm going to just do divide by plus, then obviously the formula is plus the MSC in the bracket MSC of model B divide by the standard deviation of model B. So once again, the formula here is to get the weight for model A, it is the MSC of model B, which is 5018.15, divided by the standard deviation of model B, which is 7078.63. Overall, that's the numerator, and the denominator is a sum of two more ratios, which is the MSC of model A divided by standard deviation of model A, which is 4812.89 divided by 7267.38 plus the standard MSC of model B divided by the standard deviation of model B. So therefore my model A weight is 0.5177 and model B weight is obviously 1 minus of that, which is 0.48228. So what the plan will be, now I'm going to use those two weights, and then what I will do is I will multiply with its respective weight. So model A weight is B19, and I'm going to put dollar signs before that, so in that way I can easily stretch it for other values, plus value of model B times then obviously in a model weight of model B, which is B20, and I'm going to write dollar 20, and that's it. So now my values, the ensemble value is obviously 1617. I can then now stretch it for other values. These are not right, so these are my new 12 values. Now to obviously illustrate that, I can copy this, and then I can then obviously do it in many ways. So if I wanted to plot this, these are my next 12 values that obviously look like this. So then I can obviously chart these graphs based on whatever I need to do. So once again, you do these ensemble approaches when the models you have, both of them are not great. In this example, obviously, we are using a standard data set, which is Amtrak, and in Amtrak, both the regressions and with seasonality and the whole winters really performed well. You will get around less than 4-5% of error in the map. So obviously this is not a great example to demonstrate the power of Ensemble, but this video is all about showing you how to calculate the ensembled values. Thank you for watching this particular video.